NASA's Europa Clipper makes history. First space radar test, success on Mars. Imagine a world where scientists can uncover the secrets of a hidden ocean, buried deep beneath the icy surface of a distant moon. This is exactly what NASA's Europa Clipper spacecraft is setting out to achieve, and it just took a massive step forward by successfully testing its radar system, Reason, during a close flyby of Mars. But here's where it gets really interesting. This test was impossible to perform on Earth, and the results are providing scientists with a treasure trove of data to analyze. As we delve into the details of this groundbreaking test, you'll begin to understand just how significant this mission is and why it's sparking so much excitement in the scientific community. The Europa Clipper spacecraft is on a mission to explore Jupiter's icy moon Europa, which is believed to harbor a hidden ocean beneath its surface. This ocean is thought to have the potential to support life, making it a prime target for astrobiological research. The radar system, Reason, is designed to peer beneath the surface of Europa and detect signs of this hidden ocean. But before it can do that, it needs to be thoroughly tested, and that's where the Mars flyby comes in. During the flyby, the spacecraft flew within 550 miles of the Martian surface, using the planet's gravity to reshape its trajectory and send it on its way to Jupiter. And this is the part most people miss. The radar test was a crucial component of this flyby, allowing scientists to calibrate the instrument and fine-tune their analytical tools before the spacecraft reaches Europa in 2030. The test was a resounding success, with the radar system operating flawlessly and gathering a staggering 60 gigabytes of data. This data will be used to investigate how material from Europa's subsurface ocean might rise through the ice and reach the surface, as well as to study surface features like ridges and examine how they connect with structures detected below the ice. But what's really controversial is the fact that some scientists believe that Europa's hidden ocean could be home to extraterrestrial life. While this is still purely speculative, it's an idea that's generating a lot of excitement and debate in the scientific community. As Don Blankenship, principal investigator of the radar instrument said, "We got everything out of the flyby that we dreamed. The goal was to determine the radar's readiness for the Europa mission, and it worked. Every part of the instrument proved itself to do exactly what we intended." The radar data will also allow scientists to study the surface features of Europa in unprecedented detail, including the moon's ice shell, subsurface ocean, composition, and surface geology. And this is where things get really interesting. The mission has 3 core science objectives, including measuring the thickness of Europa's ice shell, analyzing the moon's composition, and characterizing surface features and geology. By conducting a detailed survey of Europa, the mission will help determine the habitability of this ocean world and expand our understanding of potentially life-supporting environments beyond Earth. So, what do you think? Do you believe that Europa's hidden ocean could be home to extraterrestrial life? Share your thoughts in the comments below. The Europa Clipper mission is a nationwide collaboration led by NASA's Jet Propulsion Laboratory in Southern California and managed by Caltech for NASA. With its powerful suite of instruments and cutting-edge technology, this mission is poised to make some groundbreaking discoveries that could change our understanding of the universe forever. Never miss a breakthrough. Join the conversation and stay up to date with the latest news and discoveries from the world of science and technology. NASA's Europa Clipper, groundbreaking Mars flyby and radar system test. Are you spending too much time chatting with AI? It's a question we're all starting to grapple with, and OpenAI, the creators of ChatGPT, are taking it seriously. In a move that signals a shift in how we interact with these powerful tools, then rolling out updates designed to prioritize user well-being and ensure a more balanced experience. Let's dive in. Recently, a close Mars flyby allowed NASA's Europa Clipper spacecraft to test its radar system. But that's not what we're talking about today. We're focusing on how the AI world is evolving to better serve us. It's no secret that generative AI assistants like ChatGPT are becoming incredibly popular. In fact, The numbers are staggering. ChatGPT boasts nearly 700 million weekly active users. That's a massive audience, and it highlights the growing role these AI tools play in our daily lives. But with this increased usage comes a responsibility, and OpenAI is stepping up to meet it. Unlike many online services that measure success by how long users stay engaged or how many clicks they generate, ChatGPT is taking a different approach. They're focusing on whether users are leaving the platform feeling satisfied and having accomplished their goals. They're also closely monitoring NASA's Europa Clipper radar ACES Mars test, a glimpse into Jupiter's icy moon. Imagine unlocking secrets hidden beneath the frozen surface of a distant moon, secrets that might just reshape our understanding of life beyond Earth. This isn't science fiction. It's the real mission of NASA's Europa Clipper, and its journey just passed a critical milestone that has the scientific community buzzing with excitement and perhaps a bit of debate. Earlier this year, NASA's Europa Clipper spacecraft successfully demonstrated its cutting-edge ice-penetrating radar during a daring flyby of Mars. Why is this so significant? The radar's flawless performance suggests that the probe is fully prepared for its main objective, examining Jupiter's icy moon, Europa, and snooping for signs of hidden oceans that could possibly harbor the building blocks of life itself. Launched in October 2024, Europa Clipper embarked on an epic 1.8 billion-mile, about 2.9 billion kilometers, voyage to study not only Jupiter, but also its intriguing system of moons. On March 1st, it swooped just 550 miles, 884 kilometers above Mars, performing a planned slingshot maneuver. This gravity assist was designed to gently nudge the spacecraft onto its precise path, a bit like a space billiards shot. But the real magic happened thanks to a coincidental opportunity. Here's where it gets even more interesting. Engineers seized this close encounter with Mars to put the spacecraft's two most important scientific instruments, especially its radar system called REASON, Radar for Europa Assessment and Sounding, Ocean to Near Surface, to the test in the challenging environment of deep space. The radar sent out signals that bounced off Mars's volcanic landscapes without a single glitch, and the resulting 40-minute experiment generated a hefty 60 gigabytes of crucial data. According to NASA, this outstanding outcome proves that the technology is operating not just as intended, but perhaps even better than anticipated. Don Blankenship, a research professor at the University of Texas at Austin and the REASON Instruments lead scientist, summed up the team's excitement. "We got everything out of the flyby that we dreamed." The goal was to determine the radar's readiness for the Europa mission, and it worked. Every part of the instrument proved itself to do exactly what we intended. But why all the fuss about this radar? Here's the part most people miss. REASON doesn't just take pictures. It's designed to beam radio waves that can penetrate Europa's thick, icy crust and bounce off features hidden deep below. Structures that could tell us whether vast, unseen oceans lie beneath and whether those waters might support some form of alien life. The technical setup is just as fascinating. Europa Clipper boasts two pairs of slender, extended antennas attached to massive solar arrays, themselves the size of a basketball court. These antennas stretch 58 feet, 17.6 meters across, maximizing their ability to send and receive faint echoes from deep within the ice, all while relying on solar panels built to capture as much weak sunlight as possible in Europa's far-off neighborhood, where the sun is just a glimmer compared to what we enjoy on Earth. Here's a bit of space engineering trivia that might surprise you. Although NASA's Jet Propulsion Laboratory performed extensive outdoor prototype testing using towers perched on hillsides, the actual flight hardware couldn't be tested that way. To protect it from contamination, the real instruments had to be assembled and checked indoors, a challenge since a proper echo test of the full system would require a chamber nearly as long as a football field, 250 feet or 76 meters. Cut off from such facilities on Earth? The flyby of Mars turned out to be the first chance to trial the radar system in full, as it would operate in the harsh environment of space. So what was the atmosphere like as the data started streaming in? According to Trina Ray, Deputy Science Manager for Europa Clipper, it was sheer elation. All of us would work so hard to make this test happen, and the scientists seeing the data for the first time were ecstatic, saying, "Oh, look at this! Oh, look at that!" Moments like these are rare, and they showcase the human passion and curiosity that drives space exploration forward. As of now, Europa Clipper has ventured roughly 280 million miles, 450 million kilometers from Earth. But its journey is far from over. The spacecraft will receive another crucial gravity assist as it swings past Earth in December 2026, setting it up for arrival in Jupiter's system in 2030. That's when the real work begins, conducting no fewer than 40 flybys of Europa, each one probing beneath the ice in search of answers to some of humanity's oldest questions. The mission offers plenty of room for debate and controversy. For example, is it realistic to expect that we'll find evidence of life beneath Europa's ice? Or are we letting optimism overshadow scientific caution? And what ethical considerations would arise if signs of life are indeed found? Should we continue to probe and sample, or step back and avoid contamination at all costs? These questions are bound to spark passionate opinions. So what do you think? Is the search for extraterrestrial life worth every risk and investment, or should we proceed more cautiously? Share your thoughts and let the discussion begin.